Inside this factory, $200 million high-speed trains are engineered for Europe's fastest rail network.
Thousands of precision components are assembled here to create one of Europe's fastest trains. Heavy industrial presses force heated aluminum through precision dies to form structural profiles for the high-speed train. Precision CNC milling machines shape aluminum surfaces to create exact mounting points for the train structure.
Automated drilling systems create precise mounting holes required for structural assembly of the train body. Advanced laser scanning systems verify the structural integrity and dimensional precision of every extruded aluminum component. Automated cleaning systems prepare the machined profiles for high-strength welding in the next phase of assembly.
Heavy factory cranes place aluminum profiles onto welding tables to begin the sidewall assembly. Robotic friction stir welding systems join aluminum profiles to form a continuous sidewall structure. Precision milling tools remove excess weld material to create a smooth aluminum sidewall surface.
The welded aluminum side panels are now structurally complete and ready for the next stage of machining.
Heavy vacuum lifters place the welded side panels onto laser cutting tables for aperture machining.
Precision CNC tools refine the cut edges to prepare the aluminum wall for window frame installation.
Laser measurement systems verify the dimensional accuracy of every machined window aperture.
The machined sidewall panels are now prepared for the next stage of structural assembly.
Heavy structural beams are placed on precision jigs to begin the train underframe assembly. Robotic welding systems secure pivot plates to the unfinished steel underframe structure.
Robotic welding systems reinforce mounting brackets on the unfinished steel underframe structure.
The structural underframe is now complete and ready for integration with the aluminum sidewalls. Heavy industrial cranes position aluminum side panels onto the steel underframe to begin car body shell assembly.
Robotic systems install aluminum ribs inside the car body shell to strengthen the structural frame. Automated welding bridges fuse the roof frame to the aluminum shell to complete the main structural enclosure. Digital scanning systems verify the geometric alignment of the assembled aluminum train shell.
The aluminum car body shell is complete and ready for the next stage of structural assembly.
Precision machines bend aluminum profiles to create the curved structural ribs of the train nose framework. Industrial robots install the crash buffer structure inside the aluminum nose framework for safety reinforcement. Automated milling tools refine welded joints to shape the aerodynamic nose framework.
Industrial cranes transfer the aluminum nose framework to the next structural integration stage. Robotic welders join thick steel plates to build the main frame of the bogie. Automated assembly systems install brake discs onto the wheel set for reliable braking performance. Industrial robots install suspension springs to support the weight and stability of the train.
Integrated sensors monitor wheel rotation and operational safety of the Bogie system. The finished Bogie assembly is prepared for installation under the train during final assembly.
Automated systems route high-voltage cables through aluminum trays to form the train electrical backbone. Crimping machines attach electrical connectors to power cables before installation into junction boxes. Robotic systems install copper grounding terminals to protect the train electrical system. Robotic scanners check cable bundles to confirm correct installation before roof system integration. Heavy factory cranes lower large HVAC modules onto the structural roof beams of the train.
Robotic systems install ceramic insulators to support high-voltage power equipment on the roof. Automated drilling robots create mounting holes in the pantograph base frame on the train roof.
The roof systems are now installed and ready for surface treatment and protective coating.
Automated systems clean the aluminum car body surface before the robotic painting process begins. Electrostatic robots spray the white base coat to create a smooth, durable train surface.
Robotic painters apply the dark window band, defining the visual identity of the train. The multi-layer coating is complete, and the car body moves to final glass installation. Heavy hydraulic jacks lift the painted car body to prepare for final bogie installation. Synchronized lifting systems lower the train body onto the bogies for mechanical integration.
Engineers install hydraulic dampers to stabilize the train during high-speed operation. The mechanical integration is complete, and the train moves to final electrical validation. The newly completed ICE3 Neo leaves the assembly hall after final manufacturing integration. The ICE3 Neo represents the latest evolution of European high-speed rail technology. NextGen Machine Works, building the impossible. Subscribe to join the future.